Hello, my dear students. Our lesson today is about atomic structure of matter. As we studied in the last lesson, that matter consists of molecules. In our lesson today, we are going to study that molecules consists of smaller particle units which called atoms. What is the difference between molecules and atoms? Matter consists of molecules and molecules consist of atoms. In the last lesson we studied the water. Water, its symbol is H2O. This is the molecule of the water. It had the properties of water, but the molecule of water consists of two atoms, which are hydrogen, two hydrogen atoms, and one oxygen atoms. The oxygen atom doesn't have the properties of water, and also the hydrogen atom doesn't have the properties of water. Both of them are gas, but water is a liquid. So the molecule had the properties of water or properties of matter, but the atoms doesn't have the properties of matter. But the atoms can share in chemical reaction. Atoms can share in chemical reaction. So molecules, it is the smallest part of matter, which has the properties of matter and they can exist freely. But the atoms, it is the small particles which can share in chemical reaction. What is the atom? It is the fundamental building unit of matter. It is the smallest individual unit of matter which can share in chemical reaction. So, what can share in chemical reaction? It is the atom. Atom can share in chemical reaction. But what has the properties of matter? It is the molecule which has the properties of matter. Scientists decide to use symbols which represent each atom or each element. We can write, instead of lithium, we can write Li. This is the symbol of the atom of lithium. Potassium, we will write K. Sodium, Na. Calcium, Ca. Magnesium, Mg. Aluminum, Al. Zinc, Zn. Iron, Fe. Lead, Pb. Copper, Cu. Mercury, Hg. Silver, Ag. Gold, Au. Hydrogen, H. Oxygen, O. Nitrogen, N. Fluorine, F. Chlorine, Cl. Bromine, Br. Iodine, I. Helium, He. Argon, Ar. Sulfur, S. Phosphorus, P. Carbon, C. Silicon, Sr. How to write the symbols of the element? Of course, there are rules about how to write symbols of the element. The chemical symbols of the element. The symbol of any element represents an individual atom or one atom. If the element symbol was one letter, it's written in capital. Like here, when we are going to talk about hydrogen, I will write H, but in capital letter. We have to write it in capital. Okay? So if the element symbol was one letter, it's written in capital. Some elements have more than two letters as symbol, like helium. The symbol of helium, He. Why? Because the letter H is taken for hydrogen. And also helium, the first letter is H, so we can't write H again. We will take the second letter, which is A, but now we will write it in small letters. Again, if it is only one letter, we will write it in capital. If they are two letters, we will write the first in capital and the second in small. So some letters have more than two letters as a sample. The first letter most common in these elements, such as carbon. What is the first letter in carbon? It's C. What is the first letter in calcium? Also it's C. So in calcium we will take also the second letter, which is A, and we will write it in small. Sulfur, the first letter is S. So we will take the first letter, which is S, and we have to write it in capital. Silicon, the first letter also is S. It's common between sulfur and silicon. So here in silicon we will take also the second letter, which is I, but we will write it in small. Hydrogen and helium. Hydrogen is H and helium is HE. We will take the second letter. First is capital and the second is small. The first letter is written in capital and the second is in small. But if we notice that some letters or some symbols of the elements are different from their name, like sodium. Sodium, its symbol is Na. Why? Because these symbols are not taken from English language. They are taken from Latin language, which is different from English. Sodium name in Latin, its name is natrium. So we take the first two letters from natrium or sodium in English, we'll take Na. Na, it's the symbol of the sodium. But those two letters, they are taken from the Latin, not from the English. The sodium name in English, it's sodium, SO. We will not write SO, we will write Na, because we take these symbols from Latin, not English. Also potassium, its symbol is K. The first letter of potassium, P. We will not write P, we will write K, because the name of potassium in Latin, kalium. So some elements are not derived from English name of the elements. They are not taken from English. So they have symbols taken from Latin language, which are different letters. Now we are going to talk about the atomic construction. What is the construction of the atom? The atom consists of two parts, which are nucleus and electrons. Let's draw the atom. As we said, the atom consists of two parts, which are the nucleus, this is called the nucleus, and electrons, which revolve around the nucleus, like this. The atom consists of two parts, nucleus and electrons. The nucleus, it is the central core of the atom, and the nucleus, it is in the middle, or as I said, it is in the center. The nucleus consists of two particles, which are positive protons and neutral neutrons. What is the meaning of neutral? Has no charge. Again, what's inside the nucleus? Two particles. One of them is positive and its name is protons, and neutrons, which are neutral or have no charge. and around this nucleus electrons revolve. Electrons revolve. The atom consists of two parts, which are nucleus and electrons. At the first, we will talk about the nucleus. It is the central core of the atom. As we saw, it is in the center, where its mass and the positive charge are concentrated. The nucleus includes positive charged particles, which known as protons, and neutral particles or have no charge, which are called neutrons. The atom, the nucleus is positively charged particles. Sorry, this is the nucleus. Is positively charged particles because it contains positive protons and neutral neutrons. So this makes the nucleus is positively charged particles. Again, this nucleus is positive. Why is it positive? Because it contains positive protons and neutral neutrons. Neutrons have no charge, so we have only one charge inside the nucleus, which is positive. So the nucleus will be positive. Electrons, they are negatively charged particles. Those electrons which revolve around the nucleus, they are negative, and they have negligible mass. What is the meaning of negligible mass? Very, very small mass relative to neutrons and protons. The electrons revolve around or orbit the nucleus with very high speed. The electrons revolve around the nucleus in orbits known as energy levels. The electrons have negligible mass relative to the protons and the neutrons. Again, the electrons have very, very small mass, which is negligible or neglected mass relative to the mass of protons. The mass of protons is big, and also the mass of neutrons is very big relative to the electrons. Electrons have negligible mass. What is the meaning of negligible mass? Very, very small mass relative to what? Relative to protons and the neutrons. So the mass of the atom is concentrated in the nucleus. Why the mass of the atom is concentrated in the nucleus? Because the mass of electrons is very small or negligible relative to what? Relative to protons and neutrons. The mass of protons and neutrons is very big if we compare it with electrons. Electrons have very small or negligible mass relative to protons and neutrons. So the mass of the atom is concentrated in the nucleus. We will neglect or ignore the mass of electrons because it's very small, so it's not important. The mass of electrons is negligible because the mass of the atom is concentrated in the nucleus. Again, the electrons, as we said, they are negative. They are negative charged particles, and they have negligible mass. As I explained, what is the meaning of negligible mass? Very small mass. The electrons revolve around the nucleus is very high speed. It's moving around or orbit the nucleus. The electron has negligible mass relative to the mass of protons and the neutrons. The mass of the atom is concentrated in the nucleus, and the atom is electrically neutral. Why the atom is electrically neutral? As I said, that the nucleus has positive protons and neutral neutrons. Of course, this makes the charge of the nucleus is positive. And here we have electrons, which are negative. number of positive protons is the same of number of negative electrons. They are equal. Number of positive protons inside the nucleus equal number of negative electrons which revolve around the nucleus with very high speed. This makes the atom is electrically neutral or have no charge. Why? Because we have here positive and negative, and the number of positive protons equal number of negative electrons, so this makes it neutral. If we are talking about the sodium has positive 11 proton. Here inside the nucleus it has positive 11 proton, and here around the nucleus it has negative 11 electrons. So if we compare the positive 11 protons to negative 11 electrons, this will make the atom, all the atom is neutral because it has number of positive protons inside the nucleus equal to number of negative electrons which revolve around the nucleus. This makes the atom neutral. This makes the atom neutral. The atom is electrically neutral in its ordinary state. The number of negative electrons which revolve around the nucleus is equal to number of positive protons inside the nucleus. And as we said, that the mass of the atom is concentrated in the nucleus. So when they ask you, give reason, the mass of the atom is concentrated in the nucleus, I will say because the electrons have negligible mass relative to protons and neutrons. The electrons have very small or negligible mass relative to protons or neutrons. And when I ask you, give reason, the atoms is electrically neutral, I will say because number of positive protons equal number of negative electrons, or the number of negative electrons which revolve around the nucleus is equal to number of positive protons in the nucleus.